You can see my software program here of Bobcat V37. Switch to my other screen here. And you can see the part file that we're working on. So this is a good demo part file that we use a lot. It's going to be going from 3-axis milling. So we're roughing this part file out, doing some finish operations. For you, Leon, and some other guys that are getting into the newer versions, I think in 36 and 37 is when we started with this deep shallow operation. So we'll see the benefits to using steep shallow rather than a planer or a Z-level finish operation for a finish pass. It's sort of a 2-in-1 kind of thing. It offers Z-level finish and planar together, or Z-level finish and equidistant together as well. So we'll take a look at some of the 3-axis finish operations for this part file, and then we'll be able to see how 5-axis can benefit the surface finish with these finish operations, to be able to tilt the tool into these corners and areas like that to be able to give us the best surface finish possible. So I'll start from the beginning here of my milling job. I just sort of, I got this part file from one of our other techs here, and it was, I don't have the orientation of where it was, but it was somewhere out in space here. I'll just translate it, sort of drag it over. It was somewhere out here in space, and to be able to move it right here to the CAD origin location is pretty easy, where I'm able to right click anywhere in the CAD workspace here, and we have our entity summary. I tend to highlight this because then we're able to see how far over in the X direction, how far over in the Y direction, and how far over in the Z direction. So these minimum bounds are, X would be, I guess if you're looking down on the part, would be how far over from the left edge of the part it is, and then the maximum bounds would be on the other side of the part. So the total would be total length, total width, and total height of the part here in X, Y, and Z. So what I did, I went to translate, and for example, I wanted that bottom left corner over here. It's somewhere out in space, but that's the corner that I would be moving to our CAD origin location. I really just went into utilities, went to translate, selected the solid model, and then for my translate amount, I just right click, go to my entity summary. I just copy this number, move it over in negative X in that direction, in that amount. Go back to my entity summary. I've got my Y distance right here of how far I moved over, move it that negative distance there, and then my entity summary and how far I need to move up the Z axis from that -2 amount. I'm just going to move it up that amount there. And that's how I moved it to that exact location there on my screen. And that way I've got everything lined up with my CAD origin location right here, and my sort of my machine setup, my orientation when it comes to milling this out. And so once I've got it orientated pretty well there, I can go to the top and go to CAM. I can start a new job, and I can go to milling. And it has to be a different machine other than 3-axis mill. It has to be one of our 4 or our 5-axis milling machines to be able to do this sort of multi-axis tilt functionality here. So under the drop down for my machine, I used BC table, which BC in our software program stands for Bobcat. So it's one of our generic Bobcat machines. And table would mean that the table rotates around the C axis. You can see some of the G code that I was looking at earlier to make sure that there was some rotation of the C axis here in the G code. So the platter is going to rotate around the C axis, and then there is an A axis rotation around the trunnion of the table there. So that's our BC table. We'll be able to look at it in our simulation later. Some other 5-axis machines we have in here built into the system would be the BC head machine, where the tool itself, or the spindle, would be able to rotate around 2 axes. We have BC head table, where the spindle can rotate in one axis, the table would rotate in another axis. So we've got a bunch of different multi-axis milling machines in here. I usually use the table because a lot of our customers have trunnions to be able to rotate around one of those axes around their machine there. So I'm going to go with Bobcat table. I'm going to go to Stock Wizard, where I can define my workpiece. I'd be able to view in simulation and make sure how much material is remaining based on the workpiece I've defined here. And then I can define the stock that I'm starting with. So I'm going to be using a rectangular piece of stock like this. I can also create different types of shapes of my stock. If I'm starting with a cylindrical shape, I can go here to stock type, go to cylinder, and define it as a cylinder. I can extrude it from wireframe. I can select a solid model and hit calculate stock. That'd be pretty good if I'm working off of a casting and I can select a solid model and tell the software exactly where I'm starting from to avoid any air cutting. We could also define it as an STL file or a revolved surface. So another cylindrical shape there. That's usually used for turning, but you can definitely use it for milling as well. So I'm going to go to rectangle. I'm going to hit calculate stock again. It creates a rectangular piece of stock around my solid model automatically. If there was extra material in any of these directions, in the X direction, say I typed in 12 inches here instead of 10 and a quarter, you can see that it adds half of that amount in each side in the positive and the negative X directions. When I hit calculate stock, it will go back to 10 and a quarter. If I wanted to just go in the positive X direction, I can type in 1/4 of an inch, and I can move it over just 1/4 of an inch in the positive X direction. So then from there, it can be really helpful just to show you if we're doing a facing operation first. I can type it in the positive Z direction. I can click on 1/4 of an inch, or usually be maybe 100 thou in the positive Z direction to do a facing operation first and be able to face that off before our milling operation there. So I'm just going to leave it to our original numbers here, 10 and a quarter in X, 10 in Y, and about 3.784 it looks like in Z. And so I'll just leave those numbers to where they are. We go down to the bottom of the stock definition page here and click on next. And then we have our machine setup. This is where I'm defining my work offset at. So if I'm touching the tools off at this corner right here, or if I'm using a probe to set this as my G54 location, I would go to machine setup, click on origin, and click on that point for my new G54 work offset location. And then I click OK down at the bottom, and we have our new milling job that I just created. I'm going to delete it and go to the milling job I already have set up here, where I started with an advanced roughing operation, and I just created that by right-clicking on Machine Setup 1 in my cam tree and going to Mill 3 Axis. I selected my geometry, so I go to the top here with my selected geometry in my data entry window. I click on this checkbox, select solid body, and just select the solid model. I usually do that because if I don't select just the solid and I don't have that checked, then it's having me select individual surfaces. I think sometimes, it may be just me, but when I have 100 different selections in my selected geometry, can bog down the system. So I just select the solid model there. I'm not selecting a boundary because I'm not containing the toolpath anywhere inside a certain area. I'm just going to rough out everything that I possibly can here. And then I'm going to click OK. I'm going to go to the next page here. And we can set our rapid plane where the tool is going to rapid to, where it will feed down into the material 100 thou above our work offset location. Our top of feature where we're starting the operation is at Z0 and machining all of the stock from that 0 location of the G54 work offset location. Next page, I selected an advanced rough, and I usually get into the 3-axis milling here. For newer customers that are looking at these available operations on the right-hand side of our mill 3-axis wizard, we have our mill 3-axis standard and our mill 3-axis pro built into this mill 3-axis wizard. So you can see these first 6 milling operations, the Z-level rough, the Z-level finish, the planer toolpath, spiral, radial, and plunge rough are all in our 3-axis standard. And to be quite frank with you, I usually don't use these milling operations because everything below are our mill 3-axis pro milling operations that include everything in the 3-axis standard package here. But in the 3-axis pro, there will be many more options to optimize your toolpath. So here from the Z-level rough in the standard, in our pro, we have advanced rough. In the standard, we have Z-level finish. In the pro, we have advanced Z-level finish. In the standard, we have planer, and in the pro, we have advanced planer. We have some other 3-axis finish operations in the 3-axis pro down here as well, where we have flatlands, which the software will detect all of the flat areas on the part and mill those out with a flat end mill. Equidistant would start around a boundary I select here, maybe along the edges of the outside of the part, and then offset to the center, giving us a better surface finish, sort of like our spiral toolpath in the standard. Pencil will detect any fillets and mill those out with the correct corner radius there. Advanced planer, just going back and forth across the surfaces, another finish operation. And project curves, where we can project a 2D shape down onto a 3D surface to do a 3D engraving milling operation. And we also have steep shallow, which we'll be getting into later, but we'll be getting into the roughing first and then getting into some of the finish operations like Z-level finish, planer, equidistant, and steep shallow, which is similar to those finish operations as well. So we'll get into just the advanced rough operation here on the left. Go to our next page, and we have our work offset number of G54. Our next page, we have a multi-axis post page here for every multi-axis machine. Now, we recommend not touching this at all. Our post-processor department usually configures this specific to your machine, the limits to the machine, and rotary axes, things like that. Then we go to our next page. We have our different user interface choices, standard or advanced user interface. We got into some of this last time in the 3-axis Pro and Premium toolpaths in one of our other live events. So if you want to go and check the other 3-axis milling live events, we got into surface selections and ways to set your step over based on your desired cusp height and things like that. So we're just going to be using the standard user interface today. Going into the next page where we define our tool. I'm using a 3/4 inch flat end mill for this one. I'm just using this. This is my default settings here for the roughing. So I'm going to cancel out and go back into the advanced rough that I have here. And you can see here, I've got my 3/4 inch flat end mill. I've got my spindle RPM, cutting feed rate, plunge feed rate here. Now I can use system feeds and speeds. That will calculate everything here based on the material I'm using for my stock. Or I can type in the numbers right here. I think I had it at like 5,000 RPM, and I was going at like 80 for my cutting feed rate here. I think that's about it on this page to go over. We set our tool number, coolant type, things like that on this page for our tool. And we go to our next page here. Here's where we have our tool axis control that we'll be getting into later. All of these that I started with is all going to be in 3-axis. So I'm leaving this at 3-axis, but to look at it for a second, we have automatic 3+2. So I can type in a certain angle increment here. So here, every 15 degrees, the tool the software will calculate if it's more optimal to rotate 15 degrees, rotate to 30 degrees on the A-axis, 45, 60, things like that to give us the best roughing operation. But for roughing, we usually just do 3-axis, and then we can get into 5-axis for the finish. I have a question here in the comment section. Where was the advanced UI switch? Good question. So that is right here under advanced rough. So it's right above the tool page. So if I go to the tool page and I hit previous, or if I click on advanced rough, you'll see the user interface choice. If I want to do the advanced UI, I would open it, and here's our different tabs if we were to use the advanced user interface for this selection here. And we went over the advanced user interface, I think it was 2 or 3 webinars ago. So if you scroll down after this live event, you'll see the webinar on this one, and I explained a lot of the advanced UI there. So we've got our tool page, then our tool axis control. We'll be getting into 5-axis tool axis control to tilt the tool to give us better surface finish, better finish operations for the surfaces of the part here. And then our next page will be the different cut patterns. So parallel would just zigzag back and forth across the part. Offset out would start from the center of the part and work its way outward. Offset in would start from the outside and work its way inward. And then we have our high-speed machining operations with morph spiral and adaptive roughing, where the tool will continually spiral along, keeping constant tool engagement the whole time. These are our high-speed machining operations. If you guys are familiar with Mastercam or other CAD or CAM software programs, they use the term dynamic roughing or dynamic machining, some other terms as well, but this is the same as that dynamic machining, our adaptive roughing here, our high-speed machining, and tricoidal milling as well. So then we go to our next page, and we have our depth of cut, our step over amount. I took a large depth of cut and step over because we'll be getting into 5-axis for the finish operations here. And then I'm leaving 15 thousandths of an inch for the side walls and the floors for the finish pass to clean up. Go to our next page here. We can plunge, ramp, or spiral down into the material, entering into the stock. And this center cutting tool option, if I leave it checked, it's going to select a place to plunge down into the stock. If I uncheck this box, and if there's an opening, which there's an opening everywhere along the part file from the stock, the tool will start from the side of the stock and work its way in with the side of the tool rather than plunging down into the stock. So we have that option there, and then we go to our next page. We can get into some of these options here because in the 3-axis Pro, some of the other options we have versus the standard would be rest roughing. So if I had a previous roughing operation, I can tell the software the previous tool that I used. The software will calculate any areas the previous tool couldn't fit into and calculate just that tool path. So essentially it's going to start right where we left off from the previous operation and avoid any air cutting. And we also have a machine flatlands option. This can be really useful as well, especially if I'm going down. If I set this allowance to 0, for example, and I have a step over here of 200 thou. Let's say the depth at this floor right here, as an example, let's say hypothetically it was a ½ inch. So we're going down from the top of the stock, we're going down 0.5 to here. My step over is every 0.2 or 200 thou. So its first depth is going to go down to 0.2. Its second depth is going to go down to 0.4, and it wouldn't go down to that 0.5 because it's in an increment of 0.2. So once it goes to 0.4, then it's done. The machine flatlands option would allow the tool path to do that third depth of cut of 0.5 and machine the flatlands. And I tend to leave that on just to do an additional pass. It's going to leave 15 thou for my allowance anyway, but at least it will leave that specific amount with the machine flat lands on the floors. And then we go to our next page. We have linking for each step over, our gouge check page to make sure the tool doesn't gouge into the workpiece or into a fixture that I could use. I could import that as another solid and make sure the tool avoids that. We have our advanced feed rates, some more options in the Pro, additional to the standard roughing operation here. Convert rapid moves to feed moves. If I'm not able to set a rapid rate at the controller, I can change the rapid moves in the G code to feed moves and set that rate here. I can set my feed rate where it's linking between groups of geometry to speed up that process. And a really nice feature here in the Pro is adaptive feed rates, where I can set a minimum and a maximum feed rate here. And for example, when the tool is getting into larger material, like into these internal corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. And so I'll use standard here, just for less lines of code there, or less computing time too. Last page here is MDI for manual data input. If I needed to add any G or M codes before or after an operation, I can do that here. Let's say at the very beginning of the operation, I can go to raw text, and I can go before the tool change. I can click on command, and I can add anything I want here as raw text, or if I click on comment here, it will add parentheses before and after the text I type in to make it a comment for me. And that's about it. I'm going to hit finish. I don't want to have to recompute all of that. I wonder if it adds that note in there, unless I have to compute it. But anyways, here is the toolpath in green for my roughing operation. I'm doing a depth of cut of 350. I'm doing a step over of 200. And after the roughing operation, yes, it's a nice thing to notice here is that the test comment that I typed in from MDI does add in there. I don't have to recompute the whole thing. So anyways, I've got the advanced rough, and then we get into the 3-axis finish operation into 5-axis. So we've got a Z-level finish operation right here, then the planar, then the pencil, then the steep shallow and equidistant. Now I'm going to turn everything off except for the Z-level finish to start with. I'm going to save what I have so far, and I'm going to simulate just the advanced Z-level rough and the advanced Z-level finish. And we'll see how that looks with our stock. You can see in the simulation we have the machine turned on. And I'm going to hit run. So first we have our advanced rough. And down towards the bottom, if I hit pause, you can see this progress bar. This tick mark right here when it's moving is the progress of the toolpath. And you can see once it gets from blue to this gray color, that's going to be from the roughing to the finish. So it's a great way to be able to see exactly where we're at in terms of the progress and see when the finish operation starts there. Now Z-level finish, you can see, oops, I have the 5-axis turned on, don't I? Let me just do the first roughing. I'll hit next stop, and then the Z-level finish in 3-axis. for next stop here. So there we go. In the Z-level finish, you can see how much material is remaining on the flats here. And the reason for that is because the Z-level finish only focuses on tapered walls and any curved surfaces. So you can see these walls here are cut with the Z-level finish, but not the floors. And that's one of the biggest reasons why we added the steep shallow operation. We'll get into steep shallow here. Steep shallow, we can define the tool just like any other milling operation. And here under the cut strategy page, we have a Z-level finish plus a planar toolpath, or Z-level finish plus an equidistant toolpath. So what these options are for would be the Z-level finish would follow along the curved surfaces here, the tapered walls, and then do a planar on all of these flat areas, or a Z-level finish along the tapered walls and an equidistant toolpath along the flat areas, the flatlands you could call it. So I have it here as Z-level finish and planar, so that you don't have to do a Z-level finish operation, come back with a planar toolpath. You can do it all in this steep shallow milling operation. That's why I describe it sort of like a 2-in-1, 2 finish operations in one. You've got Z-level finish and planar all together here under steep shallow. And same kinds of options as any other finish operation. You set your depth of cut, your step over amount, how you're entering into the stock. You have a rest machining option here, linking for each step over, gauge check page, advanced feed rates, and MDI page. So I'm going to turn everything off. I think the steep shallow should be the only one other than that, and the pencil toolpath you can see, I'll turn that on as well to follow along the fillets, where the tool is a 3/8 ball end mill. That's the corner radius that it's going to follow along to finish this area up here. And so I'm going to simulate what we have. I believe the steep shallow should work for this. For just one finish operation instead of having to do Z-level finish, having to do planar, equidistant, and all that. So now it looks pretty good. We did a Z-level rough, we did a steep shallow operation, which was the Z-level finish plus planar along any of these flat areas here. And then we did a fillet operation along these areas, along the corners. So if I want to see how much has been machined already, I can go here down at the bottom. There's this analysis tab. If you don't see it, at the very top of simulation, we have different tabs here. You can go to the view tab, and here's where you can show or hide your different tabs on the right hand side here. So under the analysis tab, there's a drop down, and the fourth one down is deviation. So you'll click on deviation, and then you'll hit refresh. It will load different colors on the stock here depending on how much material is remaining. So I can zoom in and I can see this very light blue color, this teal color, is somewhere between 8 thou and 26 thou remaining in the corners. Everything here in green is cut to size with a cut tolerance of plus or minus 8 thou, but then each of the darker blue colors means there's more material remaining based on the workpiece that I've selected. So over here in the corners, this darkest blue color, somewhere around 45 to 60 thou, and then when we get into even darker blue, it's 64 thou or more. Something like this is the darkest blue, so there's more than 64 thou remaining in that corner there. So it's a great The deviation page is a great tool to use to be able to make sure everything is cut to size before you run it on the machine and see that there's something oversized there. So I will close out a simulation, and we'll see how the 5-axis can machine all of that area out without having to add more milling operations to what we're doing here. So here's the first feature 3-axis, which has my advanced rough. My second feature 3-axis, we've got the advanced Z-level finish and planer and the pencil toolpath, which again, I did the Z-level finish and the planer toolpath. Those were sort of added into that steep shallow toolpath I have here. And then I dropped this feature 3-axis down. I named this 5-axis because this is going to be our 5-axis tilt milling operations that I'm doing. So from the top, we go to our next page of our machining strategy page. Same kind of milling operations, a Z-level finish and planer and pencil to start with. And we can take a look at deep, shallow, and equidistant later. And I have all of the settings set from my Z-level finish to this Z-level finish. The only thing I changed was the page after the tool page is my tool axis control. I set it to 5-axis, and I set the max angle step to 3 degrees. So this is sort of like a tolerance level, like the next page, page after. My machining tolerance is set to 1/2 thou, where every 1/2 thou it will calculate the most accurate tool path. That's sort of what this tool axis control is doing. Every 3 degrees it will rotate it and give you that kind of accuracy with the finish operation in 5-axis. So it's not going to be every 90 degrees, it'll be every 3 degrees. It's not going to be like every 1/2 degree, so it would, if you set it to a smaller number, it will be a little more accurate, but it's going to be more tilting and more movement, more lines of G-code necessarily there. So my next page, I'm starting from the top with my finish operation, zig method, so it's just doing one directional cutting and climb milling. Setting a depth of cut of 50 thou. Setting how I'm entering into the stock, doing a circular lead in and lead out. Other than that, yeah, same. These are all the same options as I did in the Z-level finish, just only change here, sorry, 2 changes. Only change here was the tool axis control in 5-axis, and also in the gouge check page, I did this gouge check where I'm selecting my feature geometry, which is the solid model, and I'm making sure the tool and the tool holder doesn't gouge into the part itself. And the strategy I'm using is this tilt tool. So it will tilt the tool to make sure that there is no gouging anywhere along the part file as well in here. So those are the 2 changes I've made with each of the 3-axis tool paths. With the advanced planer, I changed this to 5-axis, and I set the gouge check to tilt tool. So this is really convenient because all I had to do was right-click on this feature 3-axis, go to copy with geometry, and then I right-click on the machine setup and paste the feature into my cam tree so that I've got all of my same parameters as I did in 3-axis, but the only thing I changed was 3-axis to 5-axis here, and with the gouge check, I made sure that it's tilting the tool so that there's no gouging with the tool holder anywhere along the part there. So I'm just going to turn on this feature, and we'll take a look at the tilting in simulation. And to get back into simulation and view the machine, I just wanted to make a note of this as well. The simulation showing the machine is unlocked under Machine Simulation Pro. Most customers have Machine Simulation Standard. The Machine Simulation Pro is unlocked automatically when you have 4-axis Pro unlocked in your software or higher. So if you have Mill 4-axis Pro, Mill 5-axis Standard or Pro, you will have the Machine Simulation Pro unlocked to be able to view the machine and be able to view the tilting of the machine here. So here's the 3-axis roughing. And you can probably see one other little weird thing here is that the piece of stock is off center. So if I wanted to change that before I get into the tilting here of 5-axis, I can center it to the center of the platter here by closing out a simulation. And that is found under my machine setup. I right-click on Machine Setup 1, go to Edit, and I scroll all the way down to the bottom here under Work Offset XYZ. You can see this number here is already set to 5. That's because I've raised the stock from the table. Normally it sits in the table because here is my work offset right here, the top left corner of my stock. This location would be down at the center of my table. So I raised it up 5 inches so that my stock is raised above in 5 inches. And then I think I have to move it -X and -Y to center my stock to this location here. And so I would right click anywhere in my CAD workspace, go to Entity Summary, and it looks like somewhere around 10.3 and 10.09. So I can just copy these numbers, no problem. So I copy this number, the total width of my part in X, copy and paste, and then I can divide by 2. And then I get the Y-axis here of 10.094, copy and paste, and divide that by 2 so that it's centered up in my simulation. Now, just to go over that, the Work Offset XYZ here that you're using, you're moving the part so that you're moving the stock in simulation. You're not changing anything in the G code with this Work Offset XYZ. It's only changing the orientation of the stock in your simulation. I get that question a lot from customers because makes sense. You want to make sure that your G code isn't changing at all if you're not trying to. So I always tell customers, no, that's not going to change anything in the G code for your work offset. It's only going to change the work offset in your simulation here. Oops, looks like it's moved over the wrong way. So I have to I didn't put a negative number in here. So they have to be negative numbers to move it over. That makes sense. Move it over -X and move it down in the -Y direction. And you can notice I just click OK. I don't have to update the geometry and recompute the toolpath or do anything with the milling operations in there. It's only going to change that orientation in simulation, not change anything with the toolpath or the G code there. Mark, good question. Is the advanced UI content the same as the Mill 4 or Mill 5 or Mill multi-axis settings? Yeah, so if you go into Mill 4-axis wizard or the Mill 5-axis multi-axis wizard, you will see those tabs just like you see in the advanced UI. Yep, they use the advanced UI settings as well. Mill turn, oh yeah. Sorry, I misread that. Just, yeah, Mill multi-axis. Yep. Mill multi-axis is going to be the same as the advanced UI there. Absolutely. So now here in simulation, you can see the machine. This is the machine build for table. Again, you've got the platter and the trunnion rotation here for your A-axis. And we run through the 3-axis roughing again here. I could just hit pause and hit next op for the next operation here. Turn off my toolpath so I can see my part a little better. So this has been roughed out. You can already see the A-axis tilt here. If I turn off the machine for a second and I look at it from the side here, well, I guess you can't really see a difference, can you? You can see it if you turn on the machine though. And you can also see the tilt. Where do you see that at? You see it under... You can see it under Move List. Under this tab, you can see the X location, Y and Z location of the tool point, and you can see the C axis and the A axis rotation. So the C axis has rotated to 81 degrees. No A axis rotation yet, but it did rotate the platter around. You can see the platter rotation so that the tool can fit into certain areas there. Got something in red. I may have to take a look at that. I think that's the Z-level finish there. Spinning around like crazy, making me dizzy. But once this is finished up, I'm going to check the Z-level finish, see if I have the gouge check turned on for that. Actually, I think I may not have the tool flute length long enough for that. I think that might be what's going on. So I'm going to hit pause. I'm going to just go to next op to finish that up. And then we can turn off the machine to see the part better here. And then we can go to deviation. There may be a gouge there. Yeah, there is a gouge there. So we can see in the yellow, orange, and red colors of gouging. So yellow is anywhere between 8 and 26 thou. 26 thou and up to 45 thou is the orange, and anything 45 thou and up would be that red color of gouging into those areas. May not have turned on the gouge check for that finish operation. I'll have to check that. But to focus more on the machining here along the corners with that pencil mill, the tool tilts in 5-axis to be able to point to those corners better and be able to give us a better surface finish in these corners. Thank you, Eric, for viewing the webinar today. Yeah, so we send a survey and make sure that you see the webinar and see what the next topics are. But you can always go back to this page to view it not live and all of our other live events that we've done in the past. But yeah, so with this one, we see in simulation there's a gouging. We close out of simulation. And we go back to 5-axis here. I'm going to go to each of the gouge check pages. We've got tool and tool holder, tilt tool for each one, max tilt angle, gouge check. I have to check where that is coming from. I think it's coming from the Z-level finish and the planer. So I'll turn those off anyway. Because again, the Z-level finish and the planer, not totally necessary because we're doing this deep shallow to finish this up here. So again, we're just doing this deep shallow, pencil, and equidistant. Mark, good question. Gauss check seems unnecessary. Why did the tool want to move into the part? I think what a big issue can be would be not just the tool gouging into the part, but the tool holder. So the gouge check would be really useful. especially when we get into like the pencil mill here. Say the tool was much shorter than this, which it usually is. This is a really long tool for doing this kind of machining. Probably get some tool deflection here. But say, for example, the tool was shorter, and I'll make it that way so we can see it a little better. Say 2 inches instead of 4 inches for the protrusion length. And if I right click on an operation and backplot, I can see the tool and see this here. Now you can see, even with not having to do gouge check or anything like that, you can see with this milling operation that Bobcat still calculates the tool path for this pencil mill and goes all the way down to this location, even though the tool holder might hit the part. Now that's what the gouge check would mainly be for. I would turn on the gouge check and make sure that it tilts the tool so that it doesn't gouge into. I could do that right now because I haven't calculated anything for that yet. I usually don't hit compute right here for a mill 3-axis wizard like this. We've got 5 different milling operations in this feature. So if I hit compute, it's going to compute all 5 of those operations again. I just want to compute the pencil mill that I changed the tool with. So I can hit finish. I can right click on the pencil operation here under this feature and hit compute right here. So I'm just computing this operation individually and saving time that way. Now that I've got a shorter tool, you can see now it tilts, and that's the biggest reason, the biggest benefit for the gouge check page is because the 3-axis milling operation, best way I can explain it, the mill 3-axis operation doesn't account for the tool holder and arbor here with any collisions. That's where the gouge check page can come into play. The 3-axis milling operation will account for the tool, make sure that it doesn't gouge into the part, into the workpiece. But for the tool holder especially, it tilts the tool to make sure that it has enough clearance right here so that there's no gouging. So that's probably the best part of this gouge check page here, best way I can describe it, or the best benefit I can think of what that would be for. So we'll take a look at the simulation again. Just doing the steep shallow to replace that Z-level finish and planer and the pencil here. And that would be where our 5-axis tilt will really come into play so that it doesn't gouge with the tool holder, and make sure that it cuts everything to size as well. So these weird different colors on it are showing because it's showing just the, it starts, I think it starts with the tool. What is this under? This is under analysis. There's 2 different analysis pages in Bobcat. It's kind of strange, but the analysis page up at the top has some different options, like seeing the tool number, and the colors are showing what tool number is machining what. We've also got operation number and things like that. So it will show you different colors on the stock. So tool number 1 got all the way down to this area here. Tool number 2 got into the green. Blue was tool number 4. That's under this analysis page with the deviation report here as well. So that cleaned up with the gouge check here, and that's the main reason for the gouge check and tilting the tool. If you don't have 4 or 5-axis, you don't have that tilt tool option in gouge check. You only have the retract option. So it will retract in certain areas and avoid it, but it's not going to machine it. In the 4 and 5-axis, you have the capability to be able to, let me edit it anymore. The simulation was stalling out here. Let's try to minimize that. But anyways, oh, come on. Let me run it. Let me try to close it out. I might have to close and reopen it. But anyways, yeah, the gauge check in 3-axis gives you 2 options where you can trim and relink. I'll close and reopen here. And in the 4 and 5-axis, it gives you an additional option where you can tilt the tool, and Bobcat will tilt it so that it doesn't have any gouging with the tool or with the tool holder specifically. Now you can see, once I reopen the part file here, you can see that it has the option to add a fixture. So I have some other part files like this here. So I have other part files like this where I brought in a Kurt vise and I use this as my fixture, and I'm able to view that in simulation and make sure there's no collisions between this or anything in the machine simulation there as well. But yeah, I'm trying to think of anything else to go over today. That was the main part of it, was tilting the tool to be able to get into these corners without gouging and be able to cut everything to size here. We'll take a quick look at the simulation again, and if you guys have any questions, please let me know in the comment section. More than happy to answer anything that you guys have in mill multi-axis here today. And I want to thank everybody for viewing the live event today on going from 3-axis roughing and finishing to 5-axis to tilt the tool and give us the best surface finish here on this part file. So we looked at not only tilting the tool in 5-axis, but once everything is finished up here, we can, oops, I just hit restart. Not only do we have the 5-axis tilt that we looked at today, we also looked at the simulation and being able to go to the deviation report and load the colors in depending on how much material is remaining. So we can see that everything is cut to size by tilting the tool and using that tool to be able to fit into the corners better and not have any gouging on the side walls and things like that. Thank you, Mark, for viewing the live event today, and thank you everyone else for being engaged in the comments section. Sometimes it gets a little lonely talking to a computer screen, so glad you guys were able to comment in there. Let me know that there are people viewing this live today. Again, we did 5-axis tilt today. We're not going to have one next week or the week after. Next week is Christmas. The week after is New Year's Day. So our next live event will be January 8th. I think it's going to be a good one because it's going to be benefits and why it would be good to upgrade to the V37 software program, and also benefits for the Advantage plan, which includes things like support. So you get yearly support, annual support there, and you also get I believe some hours of online training. I have to look at our list of the benefits of the Advantage plan, but it does offer, I know that it does offer tech support and online training where you could book an hour or a 2-hour session during the week, and we'd be able to go through part files that you have and show you how to program them from the very beginning all the way to producing G-code for your machine. So I want to thank everybody again. Thank you for viewing the live event today. We did 5-axis tilt for multi-axis machining, and we hope to see you in the next one, January 8th. Thank you, everyone. Have a great day there. See ya.